Okay, I wanted to send a short additional video because some of you are sort of getting confused with respect to photoperiod, light quality, light intensity, quantum flux density, and daily light integral. Remember that photoperiod, or the duration measurement for light, it is only concerned with the length of the light period, or the duration. What is the length of the day period? And as you probably read in your notes, actually what plants are doing, even though we say photoperiod, plants are really measuring the length of the night period. So if you, for example, have a 13-hour day, you'd have an 11-hour night. So they're really measuring the night, even though we often say photoperiod in all of our stuff. But that's kind of whatever. So for example, a poinsettia, a short day plant, has a 12.5-hour critical photoperiod. So, if I don't mess up my math here, what that means is when the night period, the length of the night, exceeds 12.5 hours. So that would mean the day is 11.5, the night is 12.5, right? That's 23/4. It will go reproductive. And in our area, that tends to happen in late September. Remember, September 21st is the equinox. That's when it's 12 and 12. So we need to go another week or two to get that extra night time duration to hit that critical photoperiod. So we're only, when we talk about photoperiod, it's only talking about the duration of the day-night. Nothing to do with light intensity. We also, as you read, are interested in light quality. And light quality is only talking about, well, I guess I'm defining it with the expression, what the quality of the light is. Or if we're talking about light as its colors, like the colors in the rainbow or whatever, as you saw in that unit, different light sources will emit, even though it looks like bright white light to you, there are different wavelengths in that. There may be more red, more blue, more what have you in there. And because plants use certain wavelengths of light, we are interested in what the quality or the emission spectrum is of different light sources. Is it giving off more red, more blue? Does it give off a lot of far red light, very little red? And you will have read and seen in the notes why we care about that. But that's only talking about the quality of what's being emitted or received by the plant. Again, it can be looked at separate from anything to do with quantity. So let's look at this quantity issue. When we talk quantity, we really then start really looking at light as a particle now, and we measure it as particles rather than sort of treating it as a wave anymore. And again, as you know, and as you'll learn as we go along, I love doing things with M&Ms, and partly because once we're done doing this demo, I can eat them. But if each of these little M&Ms is a photon, first of all, you'll see, as we talked about before, they come in different colors. Because when we look at it as a particle, all those particles may have different energy levels. Remember, energy levels of a photon correspond it back to, a given wavelength, if you will. But we have all these little photons. They are carrying different levels of energy, but each one of them is a little packet of energy. And even though they have different energy levels, when we measure light as a particle, that's what we're measuring as particles, not energy. You can measure energy, but the measurement, quantum flux density, as well as photosynthetic photon flux density, are only measuring the number of particles, the number of photons. And what it does, there's a few sort of rules we put on that measurement, though. PPFD and quantum flux density, they're the same thing, by the way. It's just two different words to describe the same measurement. Don't get confused. Are measured as moles, remember Avogadro's number, per second per square meter. A lot of times then, because we're measuring PPFD and quantum flux density, just what's hitting in 1 second, that number would be really small, so you'll often see us slap a micro on there. So usually quantum flux density and ppfd, they being the same thing. They're measured as micromoles per square meter per second. By the way, we can also measure them as micro Einsteins, the old English unit, and an Einstein and a mole are the same thing. They're interchangeable as well. So those are the two different measurements there. So quantum flux density is telling us just in this 1 second how many of these particles are hitting this square meter of area. It's almost more like an instantaneous measurement. Okay? Now there's one more caveat to be aware of with this quantum flux density measurement and its units. And that is our sensor that we use is designed to only measure the number of particles that fall within, and this is where the wavelength comes back again. It gets confusing because we keep flipping from wave to particle properties. But only particles that have the energy levels, only photons that have the energy levels that would make them fall in the corresponding wavelengths of 400 to 700 nanometers are read by that sensor. So, to summarize this and bring this home, our sensor will only read, the light sensor we would use, those things that fall within the 400 to 700 nanometer range, the particles that have that energy level. So let's say in this, the brown ones would fall outside of that. Even though they're coming out from the light source and they're hitting the plant or the sensor, it's not going to measure them. All of these remaining would have the right energy level to put them within that wavelength. And then that sensor is going to measure 1 second how many micromoles fell. And the sensor is usually about a square centimeter. So then it'll calculate that up to say then how many would have been hitting a square meter per second. So quantum flux density is kind of like this almost instantaneous measurement. Now, we may be interested in that reading also, and that can be a very valuable reading to see that the light levels are appropriate for the plant. But especially if we're growing certain crops, especially if we're growing food crops where we want to accumulate product, right? Strawberries, tomatoes in the greenhouse, things like that. Those plants, in order to be productive, to produce quality fruit and whatnot, need a certain amount of sort of energy per day, if you will. It's not just what's hitting it at 1 second that counts. It's what does it accumulate over the day that is a way to look at it. It's just another way to measure how much light the crop's getting. Rather than every second, we look at over a 24-hour period. And that is what we call daily light integral, DLI. And the units for DLI technically are moles because, again, we dropped the micro because now we're accumulating lots and we can use a bigger number. Moles per square meter per 24 hours. Now, I'm just going to tell you this is the real measure, this is the real thing, but because we say DLI daily, you'll see a lot of people dropping the 24 hours or per day and making it assumed. And also, in fact, don't be shocked if you hear people, because we know it's always measured on a per square meter, if you just hear people say, what is your daily light integral? Well, I have 15 moles. They mean moles per square meter per day, but we get sloppy on the language. So let me give you two quick examples. Quantum flux density is going to be in 1 second, and this, let's assume this is a square meter. How many of these things hit that every second? Daily light integral is let's keep measuring that constantly for 24 hours and how many accumulated over 24 hours. Another way to think of this is, because some of you are confusing photoperiod, let me get the M&Ms moved. Let's think about a garden hose running water. I can have a garden hose and it can have just a little bit of water coming out, right? And I could measure that water, that's water. How much water came out of it in just 1 second? It's quantum flux density. I can have another hose pipe. I'm terrible at drawing a hose pipe, aren't I? And it could be blasting water, right? And if I measure that 1 second, I've got a much higher quantum flux density. If I let these hoses run into a bucket for 24 hours and measure how much accumulated in 24 hours, that's daily light integral. And under this scenario, the one blasting water out, if they run water the same amount of time, it's going to have more water accumulated and higher daily light integral. But here's a little caveat to that. Let's say I have those two scenarios, and the hose that's just dripping a little bit, I let that drip for 10 hours. Or let's make it 18 hours into the bucket. This hose that blasted or goes at a higher rate, I only let it go for 2 seconds. Now, I don't know if this would occur, but hopefully the example makes sense. This one could accumulate over 24 hours or over that period of time as much water in the bucket as the one that only went for 2 seconds. So some of you were asking about photoperiod impact. Photoperiod's separate from this, but where photoperiod can have an impact on daily light integral is because of how long we run the photoperiod, and therefore we accumulate more and more light. The longer the photoperiod, the longer we can be accumulating. And we could have scenarios where we have a lower light level, but the lights are on or is on for a much longer period of time than, say, having a high light level but very short. You could accumulate more over that period of time from the lower light level. And that is a strategy people can use sometimes, is they may really ramp up the light level for a short period of time, or they may allow light levels to be sort of lower but extending that day longer, keeping the light going longer. So hopefully that helps. Quantum flux density is just a measurement of what are we getting out of that hose pipe in that 1 second. What's the flow rate right at that point? Daily light integral is over the whole period of time that we're flowing during the daylight, right? How much accumulates in the bucket. Another scenario is quantum flux density is at this second I'm standing out in the rain. How hard is it raining right on me? Daily light integral is more equivalent to if I had a rain gauge out of there and I measured how much rain fell over that whole rain event. Now, the reason we care, as you should have read in your notes, is certain plants need minimum quantum flux densities to exceed their compensation point for photosynthesis and to be able to accumulate anything. Other plants can't tolerate high light levels. It damages the photosynthetic complex. So we oftentimes do care about what the quantum flux density or PPFD is. But a lot of times when we're growing crops, as I said, when we're doing lettuce, greens, tomatoes, peppers, strawberries, things like this in greenhouse, where accumulating sugars from photosynthesis is really important, growers will talk more about what their DLI or daily light integral is that day, because they will know over that day that plant needs to be able to accumulate a certain amount of carbohydrates, if you will, from photosynthesis. And again, the light level could be lower, but if it occurs for a longer period of time, that might give you the same DLI as brighter light over a short period of time. So most growers will know that, for example, a strawberry in a greenhouse needs a minimum DLI of 15 to really accumulate good sugars. Lettuce, really DLI is not that important. We can go down to 6 or 7. The thing that it'll do on lettuce and herbs is just slow them down. So that's the difference between particularly quantum flux density and daily light integral. I hope that, even though that's been a little bit rambling, I hope one of the scenarios I gave you kind of triggers for you what we mean by these things. And again, it's just different ways of measuring light, because light's important in plant growth for many ways. So we have many different ways to sort of measure different aspects of light and express those measurements sort of different ways.